Hello, welcome to the new AP Computer Science A series, Unit 1. If you want to jump ahead to a specific topic, check out the time markers in the description. Also, I will be adding to and updating the series, so make sure to hit the subscribe button to keep up to date on all the content. Here I'm using the JGrasp IDE. You can use whatever one you want, but for instructions on how to install JGrasp, check the video description. To begin with, we must declare a class. Every program in Java must have at least one class. To do so, we'll type on the first line, public, class, and then the name of our class. In Java, classes names are written in Pascal case. That means all words are run together, and the first letter of every word is capitalized. I'm going to call my class my first program. Our class name must match our file name exactly, except our file name will have .java at the end. Otherwise, the program's not going to build. Next, we have to define for the computer where the class begins and ends. We do that with curly brackets. We'll start with an opening curly bracket and close with an closing curly bracket. Inside our class, we need methods. Every program must have at least one main method. That tells the computer where to start when we run the class. A main method must be written exactly like this: public, static, void, main, open parentheses, string with a capital S, open close square brackets, args, close parentheses. Next, we need to define where our main method begins and ends. So we do that with curly brackets again. Our main method begins after this curly bracket and ends after that curly bracket. An important rule with curly brackets is when we open one, everything after that is indented one more line. When we close one, everything after that is indented one less line. The next command we're going to learn is the system out print line. What that'll do is let us output something to our console down here. So we have system with a capital S, period, OUT, dot period, print, ln. And then we have an open close parentheses. Inside here is the information or the data we want to go to the console. In this case, we're going to use something called a string literal. A string literal is some very specific text or numbers. So we're going to open and close parentheses. That lets the computer know there's going to be a string literal inside here. And my message is going to be hello world. We must end this line with a semicolon. Certain lines of code must end with a semicolon, like system out print lines. Other ones, like public static void main or the class name, do not end with a semicolon. We have an open and close bracket to define where the main method or the class begins and ends. Let's check if we did everything right. What we're going to do is we're going to go to build and compile. This might look different if you're using a different IDE, but it'll be the exact same concept. What this does is checks the program for errors and converts it to bytecode, which the computer can run. This didn't give us any errors. That means, as far as it can tell, we didn't make any mistakes. Now, this is ready to be run. So I'm going to go to build, run, and our program ran and outputted hello world to our console. In this lesson, we are going to learn about using variables. Variables are letters or words that can store and manipulate data for us. I'm going to start by declaring a variable inside the main method. Variables declared inside a method are called local variables because they are local to the method that we've created them inside. So I'm going to declare a variable x of type int x. Ints can hold any whole number within a large range. Next, we need to initialize x. We need to give it an initial value before we really do anything with it. I'm going to initialize x by setting it equal to 10. Now that it has an initial value, I can change the value to 5. I can increment it. For example, I could set x equal to x plus 1. This is going to take the current value of x, which is 5, add 1 to it, it'll become 6, and that number 6 will become the new value of x. In Java, we can think of the single equals sign as being like a left-pointing arrow. The data on the right side of this expression will be calculated and then go into the left side of the expression, which is holding the variable x. The naming conventions for variables in Java is lower camel case. It's the same with method names. That means if we have one word or letter, it starts off and is lowercase. If we have multiple words, they are all run together with no spaces, and the first letter of every word except for the first word is capitalized. So I'm going to declare another int. I'm going to call it my final score. I have 3 words. They all run together. The second and third word start with a capital letter. The first word starts with a lowercase letter. In this case, I'm going to choose to declare and initialize on the same line. Now what I want to do is I want to output the value of one of my variables. So I'm going to say system out println, open close parentheses. I want to output the value that is stored inside the variable. I'm going to choose my final score. Notice there aren't quotation marks around my final score. If there were, it would print out my final score. Since there's no quotation marks, it's going to output the value stored inside the variable, my final score. Let's end our system out println with a semicolon. Next, let's build it. We're going to go to Build, Compile. The compiler checked to see if it could find any errors and convert it to bytecode. So far, it looks like there isn't a problem, so we're going to run it. We're going to go to Build, Run, and it outputted the value stored in my final score, which was 10, to our console. In this Java tutorial, we are going to learn about the 8 primitive data types that are built into Java. The first 4 are byte, short, int, and long. These all hold integer values, but within different ranges. The next 2, float and double, hold decimals, but double has more precision. Next, Boolean can hold either true or false. And finally, char or char can hold a single character. The ones we're going to focus on are int, double, and Boolean, because these are among the most useful. If you're studying for the AP Computer Science A exam, these are the 3 that you need to know for the test. Let's start by declaring an int, a, and setting it equal to the whole number 3. Next, let's create a double, b, and set it equal to 3.0. The compiler knows that this is an int because it doesn't have a decimal, and it knows this is a double because it does have a decimal, even though these 2 values are equal. If we want, we could set b equal to the integer 3, and the compiler would know to convert this to 3.0 for a double. However, it doesn't work the other way around. If we typed in a equals 3.0, it would not know to convert it because it would fear a loss of precision. So the error we're going to get here is incompatible types, possible lossy conversion. We can make this work by using something called casting. Casting converts it to another data type. We're going to cast this 3.0 as an int, so it will cut off everything after the decimal point before assigning the value to a. We need to be careful with this because if the value were 3.999, it would cut off everything after the decimal point, and then a would equal 3. It's important to know that casting a double to an int does not involve rounding. It involves cutting everything off after the decimal. And there is our value 3. Next, let's look at a Boolean. We'll create a Boolean C. We'll set it equal to true. We could change it later, set it equal to false if we wanted. For more information on the technical details, check out this website. You can reach it by typing Primitive Data Types Oracle into Google and then choosing the first result. In this Java tutorial, we are going to review the simple assignment operator. We are going to learn about the arithmetic operators, and we are going to learn about the unary operators. So first, let's review the simple assignment operator. We could use it in an example. We have int x, we declared x. We want to set x equal to 3, so we would do that. The simple assignment operator, which uses a single equal sign, it can be thought of as a left-pointing arrow. Whatever is on the right side of the expression is calculated and put into the variable on the left side of the expression. Now let's talk about the arithmetic operators. We could use them two ways. First, we could say system out print line and have it calculate whatever was inside here. So it would do 3 plus 3, which would be 6, and then it would output the number 6. We could also use subtraction, multiplication, or division. Division is handled differently depending on whether we are dealing with an int primitive type or a double primitive type. We will learn more about how this works later in the video. We can also use it to change the value of a variable. For example, we could say x equals 3 times 3. Or if we wanted to modify the value of x based on an old value of x, we could say x equals 3 times x, which would take the old value of x, multiply it by 3, and then take that product and put it as the new value of x. The one arithmetic operator you might not be familiar with is the mod operator, or the remainder operator. How this works is we would divide the first number by the second number, and then we would take the remainder. So for example, 3 goes into 4 one complete time, and then there's a remainder of 1. So in this case, it would output the number 1, because that is the remainder. There we go, our number 1. If we did 11 mod 3, 3 goes into 11 3 full times, and would leave a remainder of 2, so this would output 2. Finally, let's look at the unary operators. They can be used for shortcuts. For example, if we had x equals x plus 1, that would take the old value of x, add 1, and make that the new value of x. We could simplify that by saying x plus plus, which is just shorthand for x equals x plus 1. Same thing with x minus minus would be shorthand for x equals x minus 1. There is another shortcut that we can use with the other arithmetic operators. For example, x times equals 3 would be shorthand for x equals x times 3. Finally, we have the not operator. So if we had a Boolean, z equals true, and then we wanted to say system out print line not, which is the exclamation point, z, the opposite of z, which is true, would be false. So this would print out false for us. In this Java tutorial, we are going to learn about division with the int primitive type and division with the double primitive type. They behave differently. Let's start with int and let's look at some examples. For example, if we divide the number 5 divided by 3, both of these are ints, so they're going to be treated with int division. 5 divided by 3 equals 1.6 repeating. However, ints can't support any decimal portion of the number, so we'll cut everything off after the decimal and just give us an output of 1. Doubles behave differently. If one or both of the numbers is a double, it will use double division. So we divide 5.0, which is a double, by 3. It's not going to round until we get to the last digit. Dividing by 0 behaves very differently with ints versus doubles. For example, if we divide by 0, 5, which is an int, divided by 0, which is an int, we're going to get an error because we can't divide by 0 using int division. Here's our error, arithmetic exception, divide by 0. On the other hand, if we're using double division, we can divide by 0. The output will depend on the numbers. Here I'm just going to change one of the numbers to a double, and since one of the two is a double, it will treat it with double division. Since the numerator is a positive number, we are going to get a positive infinity. If the numerator were a negative number, I'm going to make this double just to show as an example, we're going to get negative infinity. If both the numerator and the denominator are 0, we are going to get NaN, which stands for not a number. So we have to be careful if we're risking dividing by 0 if we're dealing with ints. If we're dealing with doubles, we may be okay dividing by 0 because we will end up with either a positive infinity, a negative infinity, or a not a number value. In this Java tutorial, we are going to learn about operator precedence. This is sometimes also called order of execution or order of operation. Some important facts to know. Like in math, some operators will be processed first, depending on their precedence. If precedence is the same, most operations are generally processed left to right like in math. It is best to use parentheses to clarify the order of execution. We want to make it as easy as possible for other programmers to understand our code, even if they don't have a perfect understanding of order of execution. Let's look at this simplified table to let us know what comes first and last. This will cover about 99% of the circumstances you're going to run into. We can see we start with parentheses, then increment and decrement and not, then casting, like casting to an int or a double. Then we have multiplication, division, mod, addition or concatenation and subtraction, all the comparative operators, and an or. For the most part, you're just going to have to worry about the ones highlighted in yellow here. Now let's look at some code that we can trace out. We see the SOP. For the purpose of this video, this stands for System Out Print Line. We have our representation of our memory stack here, and then our output. For ease of viewing, I've color-coded the parentheses to indicate their level. So the outermost will be red, then the middle ones are green, and then the innermost are blue. Let's start tracing out the code. We'll start by declaring x and setting it equal to 5, and we see it appears on the stack. Then we'll declare y and set it equal to 6, and we see it's also here on the stack. Since parentheses have the highest precedence, we're going to look for the innermost parentheses, which are right here. There's only one operator inside these parentheses, subtraction, so we're going to evaluate 5 minus 2, which gives us 3. Next, we have to look at the other parentheses. We have two green parentheses. However, this one is further left, so this one is going to take precedence. Inside these parentheses, we have two operations, subtraction and multiplication. We can see multiplication takes precedence, so we're going to go and do 1 times 2, which will be 2. We have one more operation inside these green parentheses, 3 minus 2, which gives us 1. Now, we are finished with this set of parentheses, so we'll go over to this other green set of parentheses. There's only one operation left inside here, 3 times 3, so that'll evaluate to 9. Next, we are in our outermost set of parentheses. So we've got several different operations. We've got a cast, we've got a plus plus incrementation, we've got division, and we've got a greater than. We can see the plus plus increment, it takes highest precedence. So we'll do x plus plus. Since the plus plus is after the variable, this means that we will increase the value of x in the stack, but for the purpose of this x, it will remain at 5. Now we'll replace this x with a 5, as we increase the value on the stack to 6. Next is cast. So we're going to cast this 5 as a double, and 5 as a double is 5.0. Now we see next is division. So we'll do 5.0 divided by 1, which will remain 5.0. We have one final operation that's checking is 5.0 greater than 9. This evaluates to false. So now we system out print line false, and then we output it to the console here. In this Java tutorial, we are going to learn about two things. The first is how to cast a primitive value, and the second is overflow. Some important facts to know. First, casting primitive data types allows us to convert a piece of data from one primitive type to another. Widening means converting to a data type with either more precision, as in more decimal places, or more space, as in larger or smaller values. Narrowing means converting to a data type with either less precision or less space. For AP Computer Science A, you only need to know about the three primitive types, int, double, and boolean, but we will be covering some of the others in this lecture. Let's start by looking at some code. So here we have our code, here we have the data on the stack memory, and here we have some notes. We'll start by declaring a variable, a, of type double, and initializing it to be 3.0. Then we'll add it on the stack here. Next, we'll notice that here we're setting double b equal to 4. The 4 is an int, and the b is a double. This is what we call widening, because 4 needs to be widened to 4.0, adding precision. This can happen automatically, so then when we place it on the stack, it automatically converts it to 4.0. Now let's look at another example. Here we have double C equals double 5. The double here is manually casting it to a double. This is a good practice because it lets other programmers know what's going on, but it's not required in the case of widening. Here, we're declaring a variable d and setting it equal to c. This will cause an error when we compile because c needs to be narrowed to fit into an int value. Narrowing must be done manually. For example, if we said int d equals and we manually cast it as an int c, this would work. Then we would narrow the value 5.0 into the int value 5. Next, let's look at this example. We have int e, and we're casting 3.95 as an int. It's important to understand when we cast a double as an int, we lose the entire decimal portion of the number. So we don't round, we truncate after the decimal point. Therefore, e will be set equal to the int 3. Next, let's look at an example where we have to deal with overflow. Here we have int x equals 10. We'll place that on the stack. It's important to know that ints go to a value from about negative 2 billion up into a value of about positive 2 billion. Here we're declaring a variable of the primitive type byte y. We haven't initialized it yet. Bytes can have a minimum value of negative 128 and a maximum value of 127. On this line of code, we are setting the byte y variable equal to x. This is going to generate an error because we need to narrow x. In this case, the value of x10 is well within the range of what a byte can hold. However, the compiler is going to be concerned that x may not always be within the range we want. Therefore, we need to manually cast the int x as a byte, and then we can set y equal to it. In this case, y equals 10. There's no need for any loss of data. In this example, we're casting the number 128 as a byte. We can see positive 128 is greater than the maximum value a byte can hold. This will cause an overflow, where this number is larger than our data type can hold. In the case of byte, that means it'll roll over to the minimum value. The minimum value will be negative 128. Other data types can roll over too when they overflow. byte, short, int, and long will all overflow and wrap around to the other side. The primitive type double and float will not wrap around when they overflow. Instead, they will go to infinity if the value is too high, or negative infinity if the value is too low. Casting is one example of when we can have an overflow. However, we can also overflow a variable when we add past its highest value or subtract past its lowest value. We're going to learn about how to swap the values of two variables. Sometimes we want to switch the values of two variables. The most universal way to do this is with a temp variable. There are other ways to swap values without temp variables, but they only work with certain data types. We won't cover those today. Let's start by declaring a couple of variables and initializing them. We'll declare a variable x, set it equal to 3. Then we'll declare a variable y and set it equal to 9. We'll start by discussing a wrong way that many new programmers try. They set x equal to y and y equal to x, expecting that it'll swap the values of these two variables. Let's trace it to see what's going to happen. We set x equal to y, so it copies the y value to the x. Then we set y equal to x, which copies the x value to the y, and they both end up at 9. However, we wanted to swap these values. We wanted x to be 9 and y to be 3. Now let's look at the right way. We start by creating a temp variable and copying the value of x into the temp variable. Next, we copy the value of y into the variable x. Finally, we copy the value of temp into the variable y. Now the values are switched. Y is 3, x is 9, compared to the other way around when we started. Thanks for watching. If you enjoyed the video, please hit the like button and then leave me a comment down below. To see the next video, click on the image on the left side of the screen. To see the entire playlist for the series, click on the image on the right side of the screen. And to keep up to date on all the latest content, hit the subscribe button in the middle.